The wonder of the Northern Lights reminds us of the intimate connection we have with our star. The aurora borealis happens when solar winds hit the Earth's upper atmosphere. But many of these displays may soon vanish. Something is happening to the solar activity on the surface of the sun. It's declining, fast.
Whatever measure you use, it's coming down. The solar peaks are coming down. And for example, with the flares, it looks very, very significant.
The solar cycles now are getting smaller and smaller. The activity is getting less and less.
There is a vast range of solar activity. Sunspots, intensely magnetic areas seen here as dark regions on the sun's surface. Solar winds and UV light radiate towards the Earth. Flares erupt violently, and coronal mass ejections throw billions of tons of charged particles into space. Solar activity rises and falls in 11-year cycles, and right now we're at the peak, the solar maximum. But this cycle's maximum is eerily quiet.
I've been a solar physicist for 30 years. I've never seen anything quite like this. If you want to go back to see when the sun was this inactive in terms of the minimum we've just had and the peak that we have now, you've got to go back about 100 years. So this is not something that I've seen in my lifetime. It's not something that a couple of generations before me have seen.
The number of sunspots is a fraction of what scientists expected. Solar flares are half. Richard Harrison is the head of space physics at the Rutherford Appleton Laboratory in Oxfordshire. He says the rate that solar activity is falling mirrors a period in the 17th century where sunspots virtually disappeared.
The Maunder minimum, of course, was a period of almost no sunspots at all for decades, and we saw a really dramatic period where there were very cold winters in the Northern Hemisphere. It was a period where you had a kind of a mini ice age. You had a period where the Thames froze in the winters and so on. It was an interesting time.
Rivers and canals froze across northern Europe. Paintings from the 17th century show frost fairs taking place on the Thames. During the Great Frost of 1684, the river froze over for 2 months. The ice was almost a foot thick. The Maunder minimum was named after the astronomer who observed the steep decline in solar activity that coincided with this mini ice age. The Maunder minimum came at a time when snow cover was longer and more frequent. It wasn't just the Thames that froze over, the Baltic Sea did too. Crop failures and famines were widespread across northern Europe. So does a decline in solar activity mean plunging temperatures for decades to come?
We've been making observations of sunspots, which are the most obvious sign of solar activity, from 1609 onwards. So we've got 400 years of observations. The sun does seem to be in a very similar phase as it was in the run-up to the Maunder minimum. So by that I mean that the activity is dropping off cycle by cycle.
Lucy Green is based at the Mullard Space Science Laboratory in the North Downs. She thinks that lower levels of solar activity could affect the climate, but she's not sure to what extent.
It is a very, very complex area because the sun's activity controls how much visible light the sun gives out, but also how much ultraviolet light and X-rays that the sun emits. And they have they create a web of changes up in the Earth's atmosphere, producing effects that actually we don't fully understand.
Some researchers have gone way further back in time. Locked into the ice sheets are particles that were once in the upper atmosphere, particles that show variations in solar activity. Mike Lockwood's work suggests this is the fastest rate of solar decline for 10,000 years.
If we look at the ice core record, we can say, OK, when we've been in this sort of situation before, what's the sun gone on to do? And based on that and the rate of the current decline, we estimate that within about 40 years from now, there's about a 10 to 20, probably near a 20% probability that we will actually be back in Maunder minimum conditions by that time.
Less solar activity means a drop in ultraviolet radiation. Mike Lockwood says this seems to affect the behaviour of the jet stream. The jet stream changes its pattern. This ends up blocking warm air from reaching northern Europe. This causes long, cold winters. But what about global temperatures as a whole?
One has to make a very clear distinction between regional climate and global climate. If we get a cold winter in Europe because of these blocking events, it's warmer, for example, in Greenland. So the average is almost no change. So it's a redistribution of temperature around the North Atlantic.
The relationship between solar activity and weather on Earth is complicated, but if solar activity continues to fall, could the temperature on Earth as a whole get cooler? Could there be implications for global warming?
The world we live in today is very different to the world that was inhabited during the Maunder minimum. So we have human activity, we've had the Industrial Revolution, all kinds of gases being pumped into the atmosphere. So on the one hand you've got perhaps a cooling sun, but on the other hand you've got human activity that can counter that. And I think it is quite difficult to say actually how these two are going to compete and what the consequences then are for the global climate.
So even if the planet as a whole continues to warm, if we enter a new Maunder minimum, the future for Northern Europe could be cold and frozen winters for decades to come. And we won't even have bountiful displays of the Northern Lights to cheer us up.